As an ISEB qualified consultant with over 18 years of industry experience, he has had a wide range of testing methodologies and roles. He's had extensive experience in test management, test analysis, and performance testing through the software development lifecycle, both manual and automated. Over the last 14 years, he's specialized in functional testing arena, particularly performance testing and tuning. He's delivered many application performance management projects across a number of industry sectors, including pharmaceuticals, healthcare, telecom, media, and entertainment, utilities and government, including large volume tests for the recent Summer and Winter Olympics. Gareth.
Thank you very much.
Now we need to switch you over. There you go.
Thank you. Okay, as Andre said, we're going to take a look at SOSTA and really at our process of accelerating application delivery with continuous testing. If we think of today's users and the expectations in the marketplace, things are changing and changing quite rapidly. We have a lot of mobile and web applications now. We're moving away from the old client-server type situation. Unprecedented scale, so people want to test or want to use the applications at much, much greater volumes. Complexity of applications is changing. There's lots of third-party integrations. We are hooking into different services, different APIs, so the complexity of the whole process is changing as well. And rapid delivery. Consumers are really driving rapid delivery. The cost for change now is practically zero. So if somebody's using a particular service or an application and it's not going well, then it's very quick and very easy for them to change and to move, and the cost of that change is zero. When we're talking about the user expectations, there's three key things that we're talking about here. We're talking about functionality. So does the application does the application deliver the functionality and the user experience that they're expecting? So can people log into the application? Can they get the right data coming back from the application? The second is operability. So whilst it's functionally doing what it's supposed to do, how does it perform? Is it secure? Are they going to lose data? Does it scale? So if there's a sudden peak in traffic and a peak in demand, does the application still functionally perform? And deliverability is the ability to deliver changes and deliver improvements in a quick and meaningful manner. If we talk about the cost of change being zero, people expect applications to be updated on a regular basis. They expect enhancements. They expect security there as well. So the user expectations in the marketplace are very, very different. CI offers speed of continuous delivery. What's not to like? We have a number of different aspects of continuous integration and continuous delivery that I'm sure you're familiar with. First of all, small batch sizes. So keeping the complexity of the changes that we're putting through small. Comprehensive versioning control. The ability to understand where we are at that point in time. The ability to understand what has changed as we're going through with each of our deployments. And the version control can be at a code level, can be at a configuration file level, it can be across the whole spectrum. Automation, a key part of our framework and the SOSTA framework, is the ability to automate that process and to automate the testing of that process as well. There's going to be real return on investment if you can automate and execute effectively. Continuous feedback. When you're testing, getting the information back to the dev teams and fostering that DevOps partnership really to continually know what's going on. As you've made changes, you've gone through, you've tested, what's happening? Are the developers getting immediate feedback, or are they having to wait several days to get information back about what's been happening as a result of those changes? Emphasis on working builds. So build every change, test every build, and only promote the builds that have passed through to check-in. Consistent environments. With cloud environments, it's very, very easy for us to spin up environments, to provision kit, and make sure those environments are consistent every time. So every set of tests that you're doing, be it functional or mobile, are on a consistent framework and are on a consistent environment. Very often in the testing world, you'll feed back to the development team and they'll say, well, it worked in my environment or it worked in this particular environment. The ability to have consistent environments removes that entirely. And really promoting the collaboration between, excuse me, developers, tester, and ops. This is a poll we did back at the start of the year at a similar sort of conference to this, really asking people what their adoption with CI was. And you can see over 65% are either implementing CI or currently using CI. So it's a hot topic. Lots of organizations are moving towards it, and it's important that they understand, and you understand the ability to integrate the testing into that process as well. Apps have evolved, so applications themselves have evolved. Testing up until this point really hasn't. So if we think back to a small number of apps, 2 type tier, client server, then we have Web 2.0, through to the mobile apps that we see today, and all the different variations, all the different configurations, all the different permutations that users can access the development and the application on. Testing until this point has really been a bottleneck. So very often through the process of development, it would go to testing, and that testing phase would slow down. So the testing would probably occur later in the life cycle, so it would occur maybe after integration, and then it would drop into testing, and then bugs are found and feedback in the development team. And that's a very slow, laborious process. It's costly, and it slows the delivery of the application down. Okay, that slide. Why does it matter? We didn't have enough. This is an American slide in here. Didn't have enough testing for a very complicated project, US Health and Human Services Secretary. This was raised in the US government about the failure of their health service. So what's been missing up until this point? Mobile test automation. So the ability to move away from manual testing towards mobile test automation. With our products, TouchTest and TouchTest, you can automate the process of doing your functional and automate the process of doing your performance testing. Testing on real devices, so not testing on simulators, not testing on any specific jailbroken devices, testing on real actual devices that your customers would be using. And performance testing. Again, performance testing was one of those disciplines that was very often left towards the end of the life cycle. Bring performance testing earlier in the cycle now, and do performance testing as part of your continuous integration framework. And that performance testing can be small-scale performance testing at a database level, or it can be indeed much more larger performance testing on a user journey. And the ability to solidly integrate all of these things together in your CI framework, giving you the control and the accuracy and the results coming back in a very, very short space of time to feed that cycle. So if we think of the traditional cycle, laying the foundation of factory line here, so the assembly line, going through production, does it work as designed, does it perform under extreme circumstances, and then that iterative loop cycling around and making improvements on the products. The same is exactly the same in continuous integration. So we build, do the functional validation, carry out the performance testing as part of that cycle, and then getting the feedback and seeing what's actually happening as you're going through. So it's a very continuous, very quick, very rapid cycle as we go through. Mobile test automation, rapid and accurate test development. With TouchTest, we have a very quick and easy way to get into the object level of the applications themselves. We take a small library and we embed it in the code of the application, and that gives us the ability to build out very accurate, very robust, very reusable test cases. Reliable, maintainable test automation often starts with simply recording the user journey on the real user's device. So recording the actual gestures that your users are going through, be those custom gestures, pinch, pan, zoom, whatever it may be, recording them accurately and being able to play them back as well. Stability across mobile OS platforms. As you're running through your tests, the ability to run a bank of tests across lots of different platforms gives you the confidence and reduces the risk. Device performance measurement. So as you're running your tests, what's happening on the device? So what's the CPU, what's the memory, what's the network utilization on those particular devices? Really getting to a level of understanding of the impact of those applications being deployed on the devices. And real-time feedback via continuous integration. We integrate directly with Jenkins, so you can execute the tests, you can get the results directly back into Jenkins, and you can react to the information that's coming back to you there and then in your environment. We also have the concept of private device clouds. We talked about real devices earlier. So private device cloud is something that's fully managed and installed in your infrastructure behind the firewall. Real-time device inventory, status and availability. So there's a management interface to your device cloud so you can control what's going on. And online access for all your teams. With all of the SOSTA products, the access to the products is via your browser. So you simply log into the console via your regular desktop browser. There's nothing installed on your machine, so you're not tied to any specific machine. 24/7 secure remote access to the devices. Those are your devices to use for your tests, and you've got complete control over them. Functionally, remotely access to selected mobile device and any mobile apps. The devices that are in this device cloud don't have to be solely used for automated testing. They're actual devices, they're real devices, so they can be used for manual testing as well. In the testing world, you're not going to be able to automate absolutely everything. There still will be outliers that you can't automate, and you will have a little bit of manual testing in there. Beyond the private device cloud, we also have public device cloud. So this is hosted in public cloud. Access to all the latest devices, automatic installation, maintenance and upgrade, hosted devices in a secure data center. These are stock devices, not jailbroken devices. And that's a very, very important aspect, particularly in the iOS world, that the testing that you're carrying out is on the devices that your real users would. You're not breaking the devices, you're not having to hack the devices in any way. Seamless integration with TouchTest and CI environments. The slides got a little bit jumbled up there, but an API is available to install the apps, reboot, wake up, and launch the devices. So you've got complete control remotely of those devices. So you can, in your build cycle, you can deploy the code to the devices. You can execute a set of tests. You can reboot the devices. Whatever it needs to be is fully automated for you, and you can ensure you run through your testing. We also have performance testing, and performance testing comes in the shape of cloud test. And cloud test gives you the ability to carry out your performance testing at all cycles, at all stages of the development cycle. Very often, performance testing is often left too late in the day, and very often performance testing doesn't include production level testing. So testing it as it will actually be deployed with all your external facing firewalls, load balancers, third-party CDNs, all that sort of stuff. With cloud test, we promote the idea of testing throughout the life cycle. So at the very early stages, testing in the test lab, testing as part of your CI environment, where you're running small modular unit type tests to get information back, through into staging, where you're in a separate environment, but we're controlling it a little bit more, and you're going to introduce a different type and set of problems, through to full-scale production level testing, where you're testing it as actually as your users will. Okay? This slide's showing us a number of the different types of things that we would see. So for example, test lab, you might uncover garbage collection type issues. As you go up the tree out to production, then you're going to impact and see the network configuration, your firewall configuration, load balancing issues, and indeed if you're using third parties such as CDN, you might encounter issues with those. But it's important to test throughout each of these cycles with cloud test. Cloud computing, this is what cloud test essentially looks like. Over on the left-hand side, we have cloud test itself. So cloud test is a software appliance made up of a number of components. And that is the component that your users connect to and use that interface to do absolutely everything from creating their tests through to executing the tests and getting the results back in real time. Your performance testers, as I mentioned earlier, access it via a browser, so their regular desktop browser, whatever it may be. They access that environment. It's a very feature-rich GUI interface. They build out the test cases, and again, those test cases can be small, modular, database-level tests through to full end-to-end tests, user journeys. They then have access to our global cloud. So within the SOSTA platform, we have relationships with over 20 different public cloud providers, giving us access to 50 different geographies around the world, which in turn gives us access to thousands and thousands of servers. And that gives you the ability to run very, very large-scale tests. We recently ran, for example, the Winter Olympics test. We run up to 200,000 users. The Summer 2012 Olympics, we run over 1 million concurrent users. But it does really depends on the profile of the test that you want to be doing. If your test is only 50 users or 100 users, then absolutely you can use this platform as well. It has that flexibility. From the load injectors in the cloud, then they send the requests to the back-end server. So they send the requests, as real users would, to the back-end servers and exercise through the firewalls, through the load balancers, the web tier, all the way through the database, and give you valuable information back about what's happening during your test. During a performance test, you're going to get lots of information back about throughput and transactional response times, error rates, all that sort of stuff's going to come back. But unless you can marry it up to what's actually happening on the back-end server, so what's happening on the database and the web tier and the app servers, then it's going to be of limited value to you. And to do that, we also monitor, and we can monitor most systems generally with no installation on those environments. We can SSH in directly to them, or we can place a little piece of software called the conductor and pull those metrics back in as well. We also integrate with a lot of the third-party mainstream vendors that you'll see, so AppDynamics, New Relic, Amazon CloudWatch, all those sort of guys. If you're already using those in your organization, then we can hook directly into those and pull those into TouchTest as well. So continuous quality, much more than unit testing. So code change, Jenkins runs the unit test as expected. We then run iterative load tests via Jenkins. So we're kicking off the TouchTest test within the Jenkins environment. And we're getting the direct feedback from those tests coming back into Jenkins as well, so we can see exactly what's going on. If you're using mobile, then run functional automation on the real devices and functional and performance validations. We do this ourselves. We have a bank of about 400 tests that we run in our nightly build via Jenkins. And those are a combination of performance tests and functional tests as well. So we can see, this is a picture of the dashboards that we see within TouchTest. We get a lot of information coming back during all our tests, be them functional or performance. And that's the information that you can react to and understand whether that has been successful or otherwise, whether there's been a regression in performance or there's been a particular regression in a piece of functionality between each of your releases. So it's a very, very quick cycle. Managed to a performance baseline. One of the things within Jenkins is that we can pull out how the system performed across your build. So you can see on, say, for example, an average response time or a 95th percentile, how that has performed for a particular transaction or for all your transactions across the tests that you've been running. So you can see as you're going through, if things are slowing down, if you're making performance improvements, what's actually happening as you're stepping through. And feeding back into this continuous loop, we have another product which is called Empulse, and Empulse is our real user monitoring tool, and that gives us the ability to see for 100% of your users, 100% of the time, what they're doing on your apps and on your browsers. So it's feeding back what that user experience is, and that itself can be used to feed into your cycle. One of the issues in performance testing very often that we see is it's very hard to define exactly what the profile of your users are going to be. How many users should I have in the system? What's the mix of traffic on the site? How are people actually using this site? With Empulse, it's feeding that information back in, and it gives us the ability to feed that directly into our test planning and our performance testing. This is an Empulse dashboard. So it's given us 100% of the user 100% of the time, and Empulse answers 3 questions for us. So first of all, it tells you how fast you currently are. Okay, so we can see up here 2.89 seconds is the median response time for those pages. It then can tell us, based on business metrics, how fast you actually need to be. And by how fast you need to be, we simply mean that it's telling you, relative to your business, how fast you should perform. This chart here, the page rate versus page load. Bounce rate versus page load. Bounce rate is simply when somebody accesses your site and leaves straight away, leaves after one page request. And as the site performance gets slower, we can see the bounce rate gets up. And we can tie this into other business metrics. Bounce rate is just one of the default ones, but this could be order value or number of registrations on the site. And very often what we see is that as the site gets slower and slower, people drop off the site, people go elsewhere. Back to that zero cost of change, where people move very, very quickly away from the application or from the site. So continuous testing distributes effort. So if we think of the traditional linear approach, we go through unit testing and development into functional testing, a long, elongated period of testing, bit of performance testing at the end, and then possibly some production level testing as well. With the continuous testing approach, that time is greatly reduced. So you're condensing the cycles, you're doing many more testing cycles on much smaller units, and you're going through that process many more times, and it's obviously meriting a lot of time savings as well. It's a case study from one of our customers. FAS Mobile in the US are a mobile banking platform. They have lots and lots of customers, thousands of customers in the US. And with TouchTest, they reduced their manual testing from 4 months of manual testing now to running 1 hour overnight. So part of their continuous framework and their continuous testing, and they've greatly reduced the level of testing that they're doing. So 250 hours of manual tests running in just over 1 hour every night. Regression tests not run until feature complete, now run nightly. Fixing bugs earlier, detailed test results for developers. Because you're testing earlier in the life cycle, you're finding bugs earlier in the life cycle, and you're finding those features much earlier as well. And the feedback to the developers is significantly improved. You're not waiting to the end of the test cycle, you're not waiting to the end of the performance test cycle to feed that back and then try and work out what they did all those months ago. 25% reduction in time to market and reduced field failures. So a huge success story for those guys. I'll not go through this one. So the path to continuous testing, understand your requirements. So understand what you want to achieve in terms of the demographic of the people that are going to be using your site, how the sites are going to be used, what are the functional journeys that are going to be used. From a performance point of view, how are they going to perform on your site? Identify the cloud advantages for you. So there's lots of technology and lots of scale that you can use via TouchTest and cloud tests, which really make it very, very quick and very easy to take advantage of those cloud provisioning characteristics. If we think of it from a performance testing point of view, if we want to spin up 5 load injectors to inject some load on the system, we spin those up and we run a 1 hour test and we spin them down, and we only pay a few pence for that length of time that we've had those servers, rather than maintaining servers 24/7 in a rack somewhere that we're going to use time and time again. Automate the obvious and most critical. I mentioned earlier, you're not going to be able to automate absolutely everything, but take the things that are biggest risk to your business. What happens if the login process fails? What happens if the order process falls over after 100 users are on the system? So take the areas that are of highest risk to your business, and those are the candidates for automation. Build it into a continuous process, so connecting to a continuous process so that you can really benefit from that feedback loop and those really reduced cycles of testing. So you get a very, very quick and accurate cycle. And align the teams with actionable intelligence. This is really the collaborative aspect of it, where the development teams, the dev teams, the test teams are all working together to drive through the quality of the application itself. Okay, so that's me at the end of the slides. Any questions?